Sketch the graph of the function r of x equals 3x over x squared minus 1. And you want to make sure, of course, that we plot and label the intercepts and the asymptotes. All right, so the first thing we want to do is we want to factor the numerator and denominator, or what can be factored. Numerator in this case cannot be factored, right? It's just 3x. But on the denominator, we can factor that into x minus 1 times x plus 1. Okay. So now we should be able to find the intercepts and the asymptotes. So in no particular order, if we want to find the x-intercepts, we just set the numerator equal to 0. Right? So in this case, 3x is equal to 0, so x equals 0. Okay, so that should be the point 0, comma 0. To find the y-intercept, we plug in 0 in for x to find r of 0. You notice in this case we actually just get 0 over negative 1, which is just 0, right? Which sort of makes sense, right? Because the x-intercept is at 0, 0, so the y-intercept should be there as well. All right, so to find the vertical asymptote, we set the denominator equal to 0. So we get x minus 1 equals 0, and x plus 1 equals 0. We're actually going to get two vertical asymptotes here, right? Because we have two factors in the denominator. So we get x equals positive 1, and x equals negative 1. Remember, these are lines, right? This is the equation of a line. It's a vertical line here. For the horizontal asymptote, we have to compare the powers, right? So what is the highest degree of x that we see in the numerator? Well, that's just x to the first power. And on the denominator, the highest degree that we see is 2, right? So the degree of the denominator is 2. So what happens? What happens when the degree of the denominator is greater? Right? Then in this case, the horizontal asymptote is the line y equals 0, right? So that's always going to be the case whenever the degree in the denominator is greater. All right, so now we want to go ahead and just plot these 4 items that we just found. Okay? So we have our basic xy axis right here, right? So the vertical asymptotes are at positive 1 and negative 1. So we just draw these two vertical lines there. The horizontal asymptote is the line y equals 0, so we're just going to get something like this. And we have a point at 0, 0. Okay. All right, so now here we need to have a little bit of knowledge about the vertical asymptotes, right? What is the graph doing, right? Well, here's a horizontal asymptote, here's a vertical asymptote. So the graph is probably going to follow the horizontal asymptote this way and go up, or we're going to follow the horizontal asymptote below and then follow the vertical asymptote down that way. But then how do we know which one, right? How do we know what the graph is doing? Right? So there's an easy way to do this is just to plug in a point, right? Let's plug in the point f of negative 2. Plug in negative 2 into the function and see what we get. Right? So 3 times negative 2 is negative 6. Negative 2 squared is 4. 4 minus 1 is 3. So that gives us negative 2. So when x is negative 2, the y value is negative 2 as well. So hopefully that tells us what this graph may be doing, right? But just to be sure, let's put another point like negative 4, okay? So we can put a negative 4. 3 times negative 4 is negative 12. Negative 4 squared is 16. 16 minus 1 is 15. So we get about negative 4/5, right? So when x is negative 4, the y value is negative 4/5. So hopefully that makes it more clear, right? We're going to follow the horizontal asymptote that way and go down the vertical asymptote, okay? All right, so what about in between? Now there's a couple options, right? So similarly, we could be following the vertical asymptote that way. We can touch that point and bounce back around, or we can follow the vertical asymptote and cross that point and then go down, okay? So a couple of things we could be doing. So there's only one way, right? We have to plug in a point. So now in this case, the only point we can plug in is negative 1/2, okay? When we plug in negative 1/2, notice what we get. We get negative 3/2, okay, on the numerator, and then 1/2 squared is 1/4. 1/4 minus 1 is negative 3/4. So I don't really know what that number is, but the one thing I do know is that a negative divided by a negative becomes a positive. So we're going to be up here somewhere. Okay? So hopefully that makes it more clear, right? We're going to follow the vertical asymptote, touch that point, touch that point. Now we have to determine, okay, are we going to bounce back around and go back up that way, or follow the vertical asymptote down? Once again, only one way to do that. We've got to plug in a point. Let's try positive 1/2. 3 times 1/2 is 3/2. And then 1/2 squared is 1/4 minus 1 is negative 3/4. Similarly, I really don't know what that number is, but I do know that it's negative, right? So there we go, right? We're going to follow that point and go down. Remember, these are we call these graphs, smooth curves, right? So we're not going to do anything squiggly. We're not going to, go back around, make any sharp curves, okay? And also, we've already determined that this is the only intercept here, right? So we're not going to cross it again anywhere else. Okay? So last thing then, we'll just plug in f of 2. We'll plug in 2 and we'll figure out what happened. So 3 times 2 is 6. 2 squared is 4. 4 minus 1 is 3. That gives us positive 2. So our graph is going to be up here, right? So that tells us then that our graph should be above the horizontal asymptote that way, and we should follow the vertical asymptote in this direction. Okay, now, this is just a rough sketch. Okay, it's not perfect. We didn't use graph paper or anything like that, but as long as you get this general idea, right, understanding what happens around the vertical asymptote and the horizontal asymptote, and we only have one intercept in this case.